My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 603. In this lecture, we will try to understand convolution on color images or convolution over RGB images. So, till now, we have seen convolution on grayscale images or black and white images. How do you do convolution on color images? As many of you may know, color images are formed using three images. Suppose you have an image here. Suppose you have a pixel here. What it is? This is basically color image. This pixel is represented by three values, one corresponding to red, one corresponding to green, one corresponding to blue. Let me compare this color image with the grayscale image. So in a grayscale image, what you have here, it is basically a matrix. What you have here is a matrix. What are the values? It's a matrix with values from 0 to 255. In the case of color images, what you have here, literally in the case of color images, what you have literally is, you have basically a matrix wherein each cell, you have a triplet. In each cell, what do you have? Just see, in the case of color image, in each cell you have triplet, whereas in the case of grayscale image, in each cell you have only single number, just like 255, 0, 128. But whereas in the case of color image, each pixel is represented by triplet, something like 240, 130, 148, like this. Just understand. I request all of you to understand this difference. Just see, it is grayscale image, you have only one value. But if it is color image, not one value, you have RGB, you have value for R, you have value for G, green, you have value for blue. You have three values here, you have three values in the context of, in the case of color image, each pixel is represented by triplet. So, if you go to Wikipedia, just go to Wikipedia, if you go to Wikipedia and look for color images, this is a nice example. I will provide a reference link in the description section. Imagine this is RGB image. What is this? Anyway, I will provide link for this particular page. This is RGB image. There are many ways of representing color images. RGB is one of the popular way of representing the color image. There are other ways also in an image processing and computer vision. In the case of image processing and computer vision, people have come up with many ways of representing images for various purposes. The simplest one is RGB, isn't it? Which one is simplest one? Simplest one is RGB. When you break this image, just see, I am taking this color image, RGB image. When you break this image, just see, when you break this image, this is nothing but instead of thinking each pixel here corresponding to three values, the other way to think about it, the alternative way of thinking about it is, there are actually three images. First image, just see what I'm, instead of pixel, just I'm saying something about image itself. I am breaking this image into three images. Image 1, image 2, image 3. Image 1 is related to red color, image 2 is related to green color, image 3 is related to blue color, isn't it? Therefore, instead of thinking each cell has three values, the alternative of thinking about is that there are three images. isn't three images or red image RGB, isn't it? Which RGB, what is RGB image? which are combined together. If I combine, what happens? Just see, in the case of pixel, if you consider pixel, it has triplet 255, 125, 130 like that. But here I'm discussing about image itself. You can break the image into 3 images: image 1, image 2, image 3. Whereas image 1 is red image, image 2 is green image, image 3 is blue image. Even you can understand in terms of pixels, or even you can understand this in terms of images itself. Just see, R image, G image. Yes, blue, red image, green image, blue image, isn't it? Just see, if you combine, what happens? RGB, which are combined together. You have R image, isn't it? Just see here, you have R image here, isn't it? You have G image, you have B image, means red image, green image, blue image. If you combine together, if you combine all of them, is what to get is a color RGB image. This is an alternative of thinking about it, isn't it? First way is thinking about pixel. Now I am discussing about image itself. So you can think of each of these individual images. Just say this one. If I combine them, if you combine red image, green image, blue image, we will get color image. That is, what is color image? That is RGB image. If you take individual image, if you take, just let me take individual images. If you take this individual images, what are the individual images? Red, green, blue. If you take just blue image, let me consider just blue image. What is blue image? Just if you take just blue image, it's exactly like a grayscale image with values between 0 to 255. So you can think of this basically as 3 matrices, isn't it? One on top of, you can think about this. This is 3 matrices, isn't it? This RGB image is combination of, so you can think of this RGB image basically as 3 matrices, one on top of the other. This is the matrix of values. I can say, what is this? This is matrix 1, matrix 2, matrix 3. It is a matrix of values. Each image is represented by matrix. In matrix, you can have values. This is also matrix, 3 matrices representing one image, isn't it? RGB image you divided into 3 images. Red image, green image, blue image, means you have 3 matrices, isn't it? So you recall tensor. Just try to recall tensors that we learned when we learn tensors. What is tensor flow? What we discussed in the case of tensor flow. When we discussed tensor flow, just how its name, why people are calling this is tensor flow. Just try to recall tensor flow classes. This is basically, just let me recall, this is 3 matrices representing one image. Just so that's what I am saying. Yes, just see, this one is 1D tensor, 2D tensor, 3D tensor, isn't it? What is 3D? 3D tensor. 3D tensor is basically what, just recall my tensor flow classes. 3D tensor is basically volume of values, isn't it? This is a 3D tensor. 3D tensor can be thought of, you can thought of 3D tensor from computer science perspective as a 3-dimensional array. Of course, 2D tensor is nothing but a matrix. What is 2D tensor? Basically, it's a matrix. 1D tensor is nothing but vector, isn't it? 3D tensor is basically like this. What is this? And this is 3D tensor, isn't it? If you combine all 3 of them and all these 3 matrices, like what will you get? Each of these matrices, again, if you combine all these 3 matrices, I will get 3D matrix, isn't it? Now, what it says, all these 3 matrices, like each of these matrix has again a grid internally. Just see, each of this matrix has again a grid internally. Each of these has values. First one has value. Just see, first one has value, second one has value, third one is also values, isn't it? Third one has values. So what you are getting is a 3D tensor. Basically what it is what you are getting, it's a 3D tensor. So color images, so color image can be represented as a 3D tensor. Why? Because each pixel, to represent each pixel in color image, I need triplet. Therefore, color images can be represented as a 3D tensor. Now, in classical image processing, these three colors, what are those three colors? Red, green, blue, RGB, are referred to as channels, isn't it? Red, green, blue are referred to as channels, and this comes from old nomenclature, old terminology of signal processing and communication, things like that. Remember, as I told you, lot of image processing concepts came from something like something called signal processing. Signal processing is a very core area in communication and electronics. So the channel is a concept from signal processing that they are borrowed from image processing, and the RGB are called three channels. What is this RGB? RGB are called three channels, isn't it? They are called as three channels. So we will represent a 3D tensor with, how can I represent this 3D tensor? With n into m into c, isn't it? When I say c, it means number of channels. C means what? Number of channels. And color image literally has three channels. How many channels does it have? Color image has three channels, red, green, blue. It is a 3D tensor of depth 3. You can think of it as this is color image, and you can of depth 3, n into m into c. See here, what is c? Number of channels are 3, isn't it? You can think of it as length. Just see, n is length, m is width, that 3 is depth, isn't it? Depth is always 3, isn't it? Now for RGB image, for color image. Now come up an interesting question. Okay, now we know how to represent color image. Now how to do convolution. Remember, we learned how to do convolution on 2D matrix, isn't it? We learned how to do convolution on 2D matrix, which is nothing but element wise or component wise multiplication followed by addition. That's what a 2D matrix convolution. What about convolution on 3D tensor? This I will discuss in my next lecture, that is lecture number 604. Thank you very much.